Alright guys, so now we're going to be factorizing using the highest common factor. So we're going to factorize using the highest common factor. And in this method, we first find the highest common factor of the set of algebraic expressions. This should be S here, expressions. We then determine the second factor by dividing each algebraic term by the HCF and placing the quotient in the brackets. Alright, so let's just do the first one, guys, and we'll see exactly what it means. The first thing we're going to do is we're going to find the HCF of this algebraic expression here. And for the first one, the first thing we want to do is find the lowest of the numbers, right, of the three numbers. We want to find the highest common factor among the numbers. And in this case, it's 5, right? We'll find the lowest variable for it. Then for the second one here, we can clearly see that x, for the x variable, x is the lowest one there, so we're going to put x. And then for the next one, we're going to put y squared. The lowest one is equal to y squared. So we know that 5 times, whoopsie. So we know that the answer is going to be 5xy squared. And then we're going to have an open bracket here. Now it says, we then determine the second factor by dividing each algebraic term by the HCF and placing the quotient in the brackets. So what we're going to do, guys, is we're going to divide through this HCF here into this. So 5 goes into 10x cubed y squared. You're going to get a 2 here for sure. Then this x goes into x cubed, gives us x squared. And this y squared goes into y squared, just gives us 1. So we're going to get 2x squared here. Then we're going to have plus 5 goes into this 5 one time. X goes into the x, leaving x. And y squared goes into y to the fifth, leaving y cubed, right? So we're going to divide the highest common factor, guys. We divide the HCF into the algebraic expressions. So the next one here, we'll have 5 going into 15, which should give us negative 3. X going into x, which would give us just 1. And y squared going into y cubed, which would just give us y. So this is actually the answer, guys. 5x y squared times 2x squared plus x y cubed minus 3y. And that would be the answer for the first question. So that's all we have to do, guys. We just have to find the HCF and divide the original equation by the HCF to factorize it. Okay, guys? Okay, so let's actually do part B now. So for part B, it's the same thing. We want to find the lowest for the r's, and in the r case, it's actually going to be r squared. We want to find the lowest for the s. In this case, it's going to be just s. We want to find the lowest for the numbers here, 9, 3, and 27, and it's actually going to be 3. 3 is the lowest factor we have, and we're going to find, well, it's 1 over 3. Sorry about that, because it's actually a denominator. Then we're going to find the lowest one for p, and it's actually going to be 1 over p. So we know that the HCF is equal to r squared s over 3p. Now what we have to do is we have to divide this through the numerator to get the values. Cool. So in this case, we actually should get this is actually going to end up being 1 over 3. Yes, that's exactly what we get. When we divide this by this, we're going to get this r squared goes into this r squared, and the 3p goes into the 9p 3 times. Then for the second one here, we're going to have a negative. R squared into r cubed gives us just r. Then s goes into s fourth, just gives us s to the 3. Then 3p into 3p squared should actually give us p squared. Cool. Then for the next one here, we're going to have a plus, and we're going to get r squared into r4 would give us r squared. S into s to the 5 would give us s to the 4. The q remains, right? Then we would have 3p going into 27p squared, and 3 into 27 would give us 9, um, and p into p squared would give us p. So this is actually the answer, guys. 1 over 3 minus rs cubed over p squared plus r squared s to the 4q over 9p. And that's the answer for that one, guys. So I pretty much want to break this down as much as I can, but let's just do the other examples and see if you'll get the gist. So for this one here, right, the first thing we want to do is we want to find the lowest common factor between 15 and 10. And the lowest common factor between these two is actually 5. 5 can go into 10 and 5 can go into 15. Then the lowest common factor among the x's is actually x, and the lowest common factor among the y's is actually y. So we would actually get 5xy, which is the highest common factor, multiplied by, we're going to divide this 5xy into the 15. So it would be 3. The 5 into the 15 gives us 3. X into x squared gives us x. Y into y gives us nothing. So it's just 3x minus this 5xy into the 10x squared, the 10x y squared. 5 into 2 into 10 would give us 2. X into x would give us nothing there. Then y into y squared would give us y. So that's actually the answer, guys. Cool. Pretty simple. All we have to do is find the highest common factor and divide through. Then we get the quotient in the brackets, right? Just like it says up top here. So for this one here, same thing. To find the lowest common factor between 18 and 12, it's actually 6. 6 can go into 18 and 12. Then the lowest for the r is actually r squared. And the lowest for the s is actually s cubed. So we're going to get 6r squared s cubed. And we're going to put this in brackets here. So in order to get the thing in the expressions in the brackets, we have to divide through, of course. 6 into 18 goes 3 times. R squared into R squared gives us 1. And S cubed into S cubed just gives us 1 as well. So we're just going to get 3 here. Plus 6 into 12 actually gives us 2. R squared into R cubed gives us R. And S cubed into S4 gives us S. So that's the answer here. And we're pretty much finished here as well. All right. So we're gonna do one more example, guys, and right, we just want to do one more example before we move on. All right, guys, so looking at this example here, and we actually have the first thing we want to do is we want to find the lowest factor of the numbers at the top, the 9, the 3, the 9, and the 6, and clearly that's gonna be 3. Then the next one would be the lowest factor for the m at the top, which would be m squared. Then we want to look at the denominator, the lowest factor for the numbers here, 5, 10, and 25, and it's 5. The lowest factor for the p, right? Well, first we're going to put 1 over 5 for this because it's under the denominator. Now for p, we want to do the same thing, and we see it's p squared, 1 over p squared. Then for the next one, it's going to be n squared, which is 1 over n squared. So the highest common factor now, it's actually equal to 3 times m squared times 1 over 5 times 1 over p squared times 1 over n squared. So we end up getting 3m squared over 5p, is that 5p squared n squared, right? Now, of course, since this is the factor now, we'll factor this out of the equation using the highest common factor. Then, of course, we're going to want the quotient in the brackets. So I'm going to actually divide these one by one to kind of give you the vibe. The first one is 3m squared, no, 3m to the 4th over 5p squared n to the 5th. If we divide it by the 3m squared over 5p squared n squared, this will actually flip, and we're going to end up getting 3m to the 4th over 5p squared n to the 5th multiplied by 5p squared n squared over 3m squared, right? So this 3 goes into this 3 one time. This m squared goes into this m to the 4 two times. This 5 goes into this 5. This squared goes into this squared. And this n squared goes into this n to the 5th. So we're actually going to end up with um, m squared, right, over n to the 3. Yeah, that's exactly what we should end up with. Right. Then for the next one, we should actually get 3 goes into 9 3 times. M squared goes into M3 one time. Then we're going to get 5 into 10 would give us 2. P squared into P cubed would actually give us P. And N squared into N squared just gives us 1. So that's 3M plus 2P. Then minus 3 goes into 6 two times. M squared goes into M squared one time, so that's it. Then 5 goes into 25 5 times. P squared into P to the 4 P squared times. And N squared into N to the 5 N cubed times. Right? Alright, pretty simple, guys. And that's the last question that we're going to look at referring to this. I may actually put an extra video with just more questions like these because it's a little hard to catch if it's the first time you're seeing it. But we'll actually do a lot more factorization related to the highest common factor. All right. So we're gonna move on now, guys, to factorizing by grouping. Hey guys, what's up? So today we're gonna be looking at factorizing by grouping. And in this method, we are normally given 4 algebraic terms to factorize. We first group the algebraic terms in pairs so that each pair of terms has a common factor. The common factor is then used to factorize each pair of terms, and a common factor is then found for the pair of factorized terms, and then the process of factorization is completed. All right. So let's just look at some examples right away. I really want you guys to get familiar with this. So the first thing we need to do is we need to group the like terms, right? We see here that we have a px and we have a qx, we have a py and we have a qy, right? So that's the first thing I'm going to do. Let's group the like terms together. Well, they basically are together already. Px plus py plus qx plus qy, right? So all I have to do now is to factor out p, right? So I can take out p out of q. I'm going to take out the p out of the px and the py, and I'm going to get x plus y. And I'm going to take out the q, a positive q, out of x plus y, and I'm going to get x plus y. Now, since p is a factor of x plus y and q are also a factor of x plus y, then we can say p plus q times x plus y, right? And right, that's basically what we do. We write this, the positive p here and the positive q in a bracket by itself and multiply it by the common bracket between them. Cool? So let's do the second one here. The second one here is showing us 3ax minus 6ay plus bx minus 2by, right? So we can see that they're already common. So all we really need to do is factor out a 3a out of this one. And we're going to get x minus 2y, right? And for this one here, we pretty much need to do the same thing. We need to factor out a b, right? A positive b. And we're going to get x minus 2y. So end up in the same situation as here, guys, where we have the same common factor here. So all we have to do is write these two phrases here, 3a plus b in a bracket multiplied by the common algebraic expression, which is x minus 2y. And this is the answer. All right, guys, so we'll factorize both of them. All right, so let's look at some examples now. All right, let's look at more examples to make sure we really get this one pat. You're very likely to get this one on the exam. Okay, guys? So since you're likely to get it on the exam, watch it, read into it, and make sure you can do questions like these. All right, guys. So looking at 3 more examples of factorization by grouping. So the first thing we're gonna do here is we're gonna factor out p out of this p 4px and 4py, and we can actually factor out a 4p out of this 4px minus 4py, and we should get x minus y. And we can also factor out a negative 3q out of this negative 3qx plus 3qy, and we should actually get x minus y as well. And of course, what we usually do is we write these two values here, which is 4p minus 3q in a bracket, multiplied by the x minus y in the bracket, and that's the answer. All right, guys, so we'll factorize this by grouping. So now let's look at this one here. We have a mx plus nx minus my minus ny. So the first thing we want to do here, guys, is group the like terms. So mx minus my, right? We want to put the m's together. And we have plus nx minus ny. So if we factor out a m here out of the mx minus my, we're going to get x minus y. And if we factor out a n here, we're going to get positive n x minus y. And of course, we put the m plus the n in brackets, m plus n multiplied by x minus y. And once again, we factorize by grouping. All right, guys. All right, so for this one here, guys, we already have this question in the state, which is like this state here, where we can already put it, put these two in brackets. So we're actually gonna get lm plus 3pq in a bracket. Then we can put the common factor there, which is 5x minus 1. And we already factorized by grouping here because we didn't have to group the like terms. They already did it for us from the beginning. All right, guys. All right, so it's pretty simple, factorizing by grouping. I want to do more examples, and I want to do an extensive video on factorization. So we'll definitely do more of these. But that's it for now, guys, and I'll see you in the next lecture. Okay? That's it, and I'll see you in the next lecture. And remember to do your best, and God will do the rest.